funny, so let me see if I can get this one done nice and quickly here. So this is a system of 3 equations and 3 unknowns, and our motivation is going to be to eliminate one of the variables so that way we can change it into a system of 2 equations and 2 unknowns, which we're hopefully more familiar with. So let's see, to begin with I'm going to take, I got it, I'm going to take this top equation and write it here. So we have 2x plus 5y plus 2z equals negative 18, and then I'm going to take this top equation and I'm going to write it here, but I'm going to multiply it by the number negative 2, because when I multiply that top equation by negative 2, you might notice that I get x times negative 2, there's a negative 2x, y times negative 2, which would be a minus 2y, and then z times minus 2, which is negative 2z, equals negative 9 times negative 2, which is positive 18. Okay, now taking those equations and adding them together yields 2x minus 2x canceling itself out, 5y minus 2y giving me 3y, 2z minus 2z canceling themselves out, and negative 18 plus 18 becoming 0. So in other words, 3y must be 0, and then I can divide both sides by 3, and y is equal to 0. Okay, excellent. Now let's take that information and come back to our original problems. So now I'm going to take the top equation. Let's see, do I have another color here? Let's go orange. Okay, top equation. Come down here and replace the y with the value of 0. So x plus 0 plus z equals negative 9. In other words, x plus z equals negative 9. And then we will take the bottom equation, and on the bottom equation, if we replace y with 0, we would get negative x plus 6 times 0 minus 3z equals to 19. Therefore, with the 6 times 0, we end up getting the equation minus x minus 3z equals to 19. So now we have these two equations, and notice that we have two equations now that only have x's and z's in them. So I'm going to bring them together over here into another calculation, another system. So here's x plus z equals negative 9, and here is negative x minus 3z equals to 19. If we were to add these equations together, the x's cancel because x minus x is 0. Z minus 3z would be negative 2z, and negative 9 plus 19 is 10. So now we can divide by negative 2, and we end up getting z equals negative 5. So now we have a z equals negative 5, we have a y equals 0. We can take these two values and replace them into really any of our old equations. So I'm going to come back here using blue, go into this one and say x plus the value of z, which we figured out to be negative 5, must be equal to negative 9. So add 5 to both sides of the equation to yield x equals negative 5 and 5 cancel, and negative 9 plus 5 is negative 4. So therefore, our final answer to this problem overall is x, y, z equals the x value of negative 4, the y value of 0, and the z value of negative 5.